like the sprinkles are sentient and they're there to fucking rip up your tongue. We don't want that. We want them to look natural. Hey there everybody, and welcome back to another Blender tutorial, where in this one we're not only making ice cream, because this isn't like a toddler Blender tutorial channel. You put your iPad in front of your 3-year-old, you're like, I'm not going to be a parent, you watch this, you little fuck. No, we're making ice cream fully procedurally with geometry nodes. Not a single modeling operation was done here. The modeling is procedural with geometry nodes. The shading's procedural. This is a tutorial that I'm going to be splitting into 2 parts because of that, because there's a lot to cover. Part 1, this one's going to be geometry nodes. Part 2 is going to be shading. Am I doing that because this way I get to stretch it out and make less tutorials and put more ads on it? No, it does make sense to split it into 2 parts. Either way, let's get started. Make sure you have Blender 3.0 at minimum. I'm going to be using 3.1, but I don't think there's any new nodes that I'm going to be using here. So just to demo, you already saw the render. We have ice cream. This is the monster node network that only makes up half of this. Again, this is just the geometry. And we have control over a whole bunch of stuff. I didn't really label any of this, but you can see this is kind of like the cone resolution, like how much is going on there. We can control the curvature. We can actually control the ice cream sprinkles, stuff like that. Whatever, let's just get started. I feel like I've completely lost my train of thought, and that's not where I like to be. I like to be in the train of thought, riding off to Valhalla. Either way, geometry nodes. Let's begin. Ice cream. Make a new geonodes network on the cube and delete the group input. In other words, delete that fucking default cube. What do we have so far? We have an invisible cube with geometry nodes modifier applied, described by this node network. And the question is, what is the special node network that generates ice cream? Well, bear with me. It's going to be quite a trip. Starting off, you might think that, so we're going to start from the cone and then we're going to make the actual ice cream on top. You might think for the cone, it makes sense to start with a cone primitive and you basically mess with this until it looks right. No, this actually makes it substantially harder because we need to kind of bake in this waffle pattern into it. And there's no real easy way to take a cone primitive and then just slap that on. You could try to do it with the material, but since I want to do it in geometry, cone's actually not the way to go. We're going to start off with a grid, which is a weird move, but just follow along. The grid is a plane object. You can see it's a 3x3, 1, 2, 3, 4, 5, 6, 7, 8, 9 vertices. The average age of a viewer here. We can bump up that vertex count. And the reason I'm going to do that is we're first going to bake the waffle pattern into here where it's nice and flat. So you can see I'm increasing the resolution. It's still a plane. It just has more geometry. We're first going to make the waffle pattern, which is easy when this thing's flat, and then we're going to curve it into a cylinder and then a cone. So we're reversing the order of operations because it's easier in this case. So we have a dense grid. How do we make the grid pattern? Well, there's a lot of ways to do this. I'm going to show you the easiest because we're not in it to do the hard thing. So anytime we want to change the geometry, right, we want to move vertices around, we're always going to use set position because we are setting the position of each point to something new. And we want that new point to be the waffle pattern. To create this, here's what I'm going to do. So follow along. We're going to use position. So we just have position data. Just using that field, tilling the farm. We're going to separate it into X, Y, Z. What is a waffle pattern, right? This cone grid thing. It is basically lines going this way on the X-axis and then lines going this way on the Y-axis. So I'm going to do first the X, then the Y. Starting off with the X-axis, how do we generate the lines going one way? I'm going to use a sine function because it's repetitive and periodic and all this. So sine function is going to take our x domain and have it go back and forth between 1 and -1. To visualize this, this isn't what we are going to do, but let's just have this offset on the z-axis, connect this here, and boom, you can see it's doing something. Not exactly what we want, but it's doing something. It's not looking very wavy because our domain is just going from -1 to 1 on the x-axis. So just take it, multiply it by a big number, and boom, you have your waves. So you can see how this kind of generates one set of lines. And to make this less intense, what we can do is we can scale this by a small number. So it's only 10% as strong. So you can see one-way waves, right? We want to do the same thing on the other axis. So just take it, duplicate it, and this time plug in the Y. And if we swap these out, now you can see it's the same thing going in the other direction. Because I want this to have a kind of a square lattice, not a rectangle, I'm going to make sure that these both have the same resolution. So 50 or whatever. Just make sure these are using the same parameter. And then you might think, how do we combine these? So again, what are we doing here? We're just making the grid pattern in case anybody, fell asleep. Wake up. So you might think that you want to add these together, their contributions to kind of generate this lattice. And that kind of makes sense. You can kind of see how this is kind of looking grid-like. But really, this is kind of more like an egg carton. So yes, this would keep our eggs safe. It's also a nice foam mat. You can do some yoga on here. But it doesn't really look like a grid. And the issue is you don't want to add one sine wave plus another one. It's going to generate this kind of double smooth curvature, which makes it look like this. Instead, I want to just say pick the biggest one instead of adding them together and it's the smooth thing. So I'm just going to use maximum. And this generates a nice grid. How did I know this? Years of experience, literally. But once you use the nodes more, you'll get intuition for this. So you can see we've generated a nice waffle cone pattern, which we can control the resolution of. By the way, the kind of important thing to note here, if you go too high, it's going to get very blocky because unlike a shader node, this is limited by the amount of geometry. So we want to equivalently bring up our grid resolution. And you can see that's getting cleaner, and we can make it even cleaner. So I'm just going to pick 200 and bring down our resolution, or our waffle cone thing. So there we go. Now that we've generated this pattern, I now want to wrap this up almost as if we printed this out as a flat sheet, stamped it, and now we want to wrap it up because now we've already inherited this. So how do we wrap it up? Well, anytime we want to set position, we just do it again. So I'm going to do this in another set position node instead of doing a big chain here. So this first set position is the waffle cone, and the second one, or I guess it's waffle, and the second one is going to be cone. So how do we take this and turn it into a cylinder or a cone? Well, first of all, this one's purely cosmetic, but I'm going to add a transform node and just rotate this on the y-axis by 90 degrees. So it's the same thing, it's just facing upwards now. It really doesn't matter, but it makes our formulas a bit cleaner. So now that it's like this, what I want to do is, as if it was a piece of paper, just connect the edges, wrap it up. The way to do this mathematically is we want to say as we go along, in this case, the x or the y-axis. Maybe we should rotate this on the x-axis instead. Yeah, that makes more sense. What we want to do is say as we go along the x-axis, in this case from negative 0.5 to 0.5, I believe. Maybe negative 1 to 1. As we go along the x-axis, have it wrap around a circle. And again, that's trigonometry, sines and cosines. So get excited, baby. It's not over yet. More sines and cosines. So position, we want to take that idea and formalize it. So I'm going to look at the x component. What do we want to do with the x component? Have it map around a unit circle. So another math. And here I'm using this new feature where you can literally just drag and drop and then type in what you want. So math, cosine, seems to work. I haven't really used it before because I'm an old grumpkin and I like things the way they used to be, but seems okay. So I'm going to take the x coordinate again, going from left to right, take cosines and sines, and we can map this to a kind of a circle vector. So combine x, y, z. This is going to be our x coordinate. This is going to be our y coordinate. And if we connect this now, you're going to see it's going to be doing some weird stuff. In fact, we can't even see it. So finally, take the z-axis and connect this here. So before, we had this issue where we had this kind of curvature, but it was getting infinitely flattened because all the coordinates were sent to z equals 0. So now if we take z, it's doing this curvature. Now, I'm aware that there's a couple issues here. One, our waffle cone pattern is gone, and two, it's almost like we're taking a sector of a circle. It's not the full thing. We'll deal with each of these on their own. So starting off with the circle not being wrapped, same issue as before with the sine wave where it was just kind of like a diagonal instead of like an actual wave. We need to increase our domain span in some sense. So I'm going to take this and I'm going to multiply it by 6 point something, seems to connect it. Again, the more you use nodes, the more you'll be like, oh, 6 point something? You mean 2 times pi? Yeah, that's the exact number for mathematical reasons. Don't worry about it. Okay, so what do we have so far? We've taken our previous thing and wrapped it around. Again, the way this worked is we looked at the x-axis and said, as we go along here, wrap it around this cosine and sine thing. That's the function of the x and y coordinates of a circle. And we said just transfer the z coordinate over. By the way, this is why we did this rotation. Otherwise, it'd get complicated. Okay, fine. But we don't have our waffle cone pattern, and also this isn't a cone, so what's going on? So the secret here, and I mentioned this a little tongue-in-cheek before, I said, yes, we did make the waffle cone pattern before, but I said, hopefully, I said that we did it, but we're actually going to be applying it after the fact. So we can still use this math, but we need to carry it over. You'll understand in a second. So how do we get this waffle cone pattern as if we wrapped not just a piece of paper, but a piece of paper with this grid thing, drawn on? Well, what we want to do is we don't need the set position since it's not working anyways. What I'm going to do is, again, this combine xyz is our waffle cone function. We want to somehow take this information and send it over here after we do the curvature thing. To do this, we actually need to capture this attribute because, again, it's happened before the transform and all this. So it's kind of like at this part in the chain. We want to take, I guess we don't need this either. We want to take this attribute. So again, I've captured this waffle cone information. It's the maximum of the sine and the sine for x and y. I'm going to take that and we can send it over to this part. How do we want to do that? Well, first we do the curvature and then, so we could do the cone or we could do, let's do this as a separate step. So what I'm going to do is first we have the curvature, and now what I want to do is I want to push this out relative to the normal. So this is now a cylinder in some sense. The normal is always going to be pointing outwards. So the normal off the surface is this way, this way, this way, like the rays of the sun. We want to push outwards in that direction. So in other words, offset. But by how much? Not just by 1. So if I take a vector math, I realize that this is a complicated tutorial. Welcome to the channel. So we don't want to just scale on the normal, which kind of goes outwards by some number, but by this capture attribute. So let's take it and connect it, which you can see does some weird stuff. It looks like it doesn't work, but it does. It does, because we just need to take this and make it less strong. So if it's set to 0, it does nothing. Add a tiny bit. And there we go. You can see our waffle cone pattern. If anything, it's very stretched out, which is kind of what you'd expect because we took this kind of 1x1 grid and made it a big circle. So we just kind of have to remap this, but whatever. You can see the grid is somewhat transferred over. If I was to bump up the resolution of it, maybe you could see it a bit better. So again, we've captured the attribute, sent it into the feature. If you don't capture, it's not going to work. Okay, so we need to clean this up to make it look better. So first thing I'm going to do is this circle. We need to make it smaller so it's not as stretched out. So again, this is our cylinder function. I'm just going to multiply it by, let's say, 1, 1, 1, so it does nothing. But if we multiply x and y, again, the sine and cosine thing, you can see we make this cylinder bigger and smaller is the idea. So we want to pick a number. That makes it look good. You could do it mathematically. I'm not. I'm just going to pick a number that looks good. So instead of just picking, by the way, z is equal to 1. Instead of just picking some number, what we could do is we can use this step to actually generate our cone where it tapers off at the very corner. Because if you can see this as kind of a scaling of the circle, we could say as we go down, take that down to 0. Do you see what I'm saying? We can add a gradient here. If you don't see what I'm saying, whatever. Just do this. You're going to do map range. We're going to look at the z component. So again, we're looking at the z component of the position as we go top to bottom. I want to say go from, I think, -1 to 1 and map it to 0 to 1. Let's see what that does. So do that for the x and do that for the y. And you can see this kind of generates a cone pattern. Again, what's happening here, as we go from -1 to 1, which I think are the wrong numbers, but whatever. As we go up the z-axis, you can see we're remapping this from 0, make it very pinched, to 1, make the radius of the circle very big. So now we just got to pick some better numbers. I think it was -0.5 is the issue. And then the maximum is +0.5. What am I doing? Why did I set that to 3? I guess what we could do is we could do it over here. So the nice thing about this is you can now see this map range is basically the shaping thing of our cone, and you can see this grid is looking a lot nicer. To make it look even better and not facetted, let's just add a set shade smooth right at the end of this. So you can see the whole idea of what we've done here, all these nodes, which would have been very hard to model, is why we did it this way, is we took a grid. Let me just show you. We took a grid. We made the waffle cone pattern, which isn't shown. We rotated it. We did the cylinder cone transformation, and then we applied the waffle cone from before. So you can see this is why geometry nodes is useful. It's for stuff like this. And again, since this is completely procedural, we can always go back and pick numbers that look a bit better. In this case, I want to pick a number that pinches this a bit more at the corner. That doesn't seem to do it. Maybe it's because the waffle cone pattern is making it is infinitely pinched at the bottom, but the waffle cone's extending it, so we'll fix that. But so we can shape that. We can also pick the resolution of this, and very cool, since this is all dependent on the position, again, we have kind of 2 bars crossed with the maximum function. We can always do a transformation here, because you'll notice in a real ice cream cones, this isn't, not that. In real ice cream cones, this isn't like that. It's kind of diagonal, I think. So we want to include that. So let's rotate our position by 45 degrees, which does create a seam, but whatever. We'll fix that too. So you can see now we have this diagonal pattern, which would have been very, very hard to model. Okay. So one thing I'm seeing here is it's kind of like trying to connect here, which doesn't make sense. In a real waffle cone, it's not like we took a piece of paper and connected it. It kind of like spirals on itself. So there's one layer kind of extending past the first one. So if we could kind of simulate that, that'd be better. So most of the work here is actually going to be for this cone. The ice cream is actually pretty easy. So to make it kind of wrap on itself and not really have the seam, but have it be more physically accurate, we could extend this. So you can see now it's extending past the connection point, but we need one fold to kind of be underneath the other in some sense. So how do we do that? Well, what we want to do is, again, that this is dependent on this radius function that we have. And we can make that a function of the x, maybe? We'll see. So I'm going to take this, I'm going to multiply it. I'm going to multiply it by a number. So you can see all this does is it just kind of extends this, right? But I want this to be a function of how far along the grid we are. So I know I'm getting in the weeds here, but this is going to make it look better. So what we could do is we could multiply this by the x function, which kind of breaks it, but that's fine because we're going to send a map range. We know in the back of our heads, this goes from either -1 to 1 or -0.5 to 0.5, whatever. Maybe it is just -0.5 to 0.5. I don't know. But either way, you can see now we get this kind of spiral function because what you want to imagine is we're taking the grid. It's so hard to visualize, and we're kind of wrapping it and then pinching it. Right? But we want to say our wrapping shouldn't have a constant kind of radius, right? We say go from a radius of 0.6 all the way to 1. So in other words, when this is both set to 1, we have the same issue as before. But when we pull this back just a little, you can see this fold is within the other fold. You can kind of see there's a spiral going on here. And you can make that spiral very exaggerated or not. Okay, whatever. And either way, we know that we could extend it past 2 pi. So, are we happy with this? Have we solved world hunger? No, we just have a cone. Doesn't even look very good. We gotta tighten this up a bit. What I'm thinking is I don't like the constant resolution, even though I said I would. So let's multiply this by a constant, so we can kind of change the aspect ratio of our grid to make it look more square-like. I don't know what the correct number for this would be. Something like that. 1.5. So before, after, maybe that makes it worse. I don't know. Either way, we have some progress here. It definitely kind of looks like a waffle cone. But again, we have this pinching problem at the bottom and some other stuff to fix. So let's see. This is our curvature step. And by the way, just a little, since we're already in the weeds here, may as well just get like lost and like suffocating in them that we're wrapping around our neck, right? Just a cool little something. Since this is a set position step, we can mix the original position with this and actually visualize what this looks like. So what we had is a piece of waffle cone using that pattern we made, and we wrapped it just like that. That's what's going on here. That's the math behind it. Okay. We want the waffle cone to not just be a scale of some number 0.02, but we also want to multiply this by a z gradient function to make it a bit softer. So I'm going to take a position field. We could use one from before, but whatever. I'm lazy. We're going to separate. We only care about the z component. And just like before, we are going to map range, -1 to 1 or negative, I don't know. Do that, multiply it, and that should soften it up a bit. Let's see. So before, after, it's definitely working. Could be better. So we just want to, there we go. So what I'm doing is I'm using this map range to create a custom z gradient, where this is very close to 0 over here. So the waffle cone has a very small strength. It's not going to be present. Then at the top, it's going to be much more. We can make it a bit softer too. Okay, are we done talking about waffle cones already? I think we should be. I think one last thing is the spiral's a bit too tight. I'm just going to increase that. Okay, beautiful. We're done talking about cones, I swear, unless we want to kind of go back and reshape this thing. But in general, we are done with this. So next step, we've made the waffle cone. Let's actually save this. I'm going to call it, can't believe I haven't done this yet, available on Patreon, because if you don't want to make this yourself and you just want to play with the nodes, Patreon, link in the description, check it out. All the cool people, 750 people are there. Either way, tutorial's free. So all this nonsense, I'm going to frame it, Shift P. This is our cone network, and you might think, again, this is difficult, and it is. But imagine modeling this yourself and then first of all, imagine doing that. It's very difficult. But two, imagine going back and saying, oh, I wanted a different waffle cone resolution. You'd have to model it again. Whereas here, we can just kind of change it. Okay. Next step, let's make the actual ice cream. I swear to God, this is easier. Let me show you how much easier it is. We're literally just going to make it out of a sphere. Why? Because it kind of looks correct already. We just kind of have to mold it and shape it until it looks kind of okay. So we have a sphere. What do I want to do with it? So again, I took a sphere and I joined it with everything from before. So now we're making a separate chain, and then it's just going to join at the very end. I want to transform, and I'm just going to reshape the sphere until it's the correct size. So I'm bringing down the radius. I'm bringing it up so it's kind of sitting up top. I want to make it a bit kind of ovally, or technically an ellipsoid, I think. So I'm scaling it on the z-axis. I need to go back to Calc 3 to know if this is technically an ellipsoid. I do not remember. But I'm just going to roughly position it. And again, it's procedural. We can always go back, add some rotation, whatever. Okay. So here's kind of the base of our ice cream. And I know it looks delicious. But to make it look even more delicious and even more realistic, we want this to not just be a blob. But if you think about what ice cream actually looks like, it kind of melts and accumulates. And if you think about how the scooping works, is you have like, it's almost like kind of ellipsoid on top the way we have it, but on the bottom there's blobs coming out of it, like it melted and then it froze. And we can simulate that. Well, not actually simulate, but we can approximate that by adding in a bunch of spheres around the border. So let's do that. How do we do it? I'm going to do it by distributing points. And for each point, we're going to add in a sphere, just so you can see what we're doing. We're going to instance on points. For each one of these points we generate, make another sphere. But don't make it that big. Tinier spheres. So you can think of this as kind of like ice cream blobs that accumulate. And I want to take this and combine it with the original. Okay. So now the name of the game is, again, making this not look like shit. Unless you ordered shit flavor at JP Licks, then, you know, it would look like this. For all you peanut butter ice cream lovers, this is essentially what you're eating, you fucking I was going to say losers. Lunatics. Don't have peanut butter on your ice cream. Personal take. To make this look better, again, the way I describe this is it kind of melts and accumulates on the bottom. So I don't want these spheres on top, only on the bottom. Luckily, we can distribute these points based on either a selection function or a density function. I think selection would be a bit cleaner. So I want to say what part of the squished ellipsoid from before, this thing, what parts of it should spawn those spheres. I think that's probably an easier way to think about it than density. So to do that, I just want to say the bottom part. So let's take the position of the sphere. I care about how high up it is on the z-axis. So I'm literally just going to extract the z-axis. I want to say, where is it greater than or less than some number? Okay, so let's take our selection, and you can see, boop, now we have a selection generation, and we want to flip it. Although this looks like it has an arrow, and that's dope. Less than. So you can kind of see what I'm going for here. It doesn't look good yet, but it's kind of like we generated these blobs on the bottom where it accumulated. Okay, let's make it look a bit better. A couple things we can do here. First of all these spheres are the same size. They shouldn't be. So let's randomize it a bit with random values. So again, right now we're just making instances. We've played this game before. But we're going to do some fanciness to it in a bit, and you'll see how. Okay, so that's one thing we can do. Randomized it a tiny bit. Second of all, I just don't like the way this looked. You know, easy looks, easy as that. So I'm just going to play with the seed and go for a different ice cream until it looks okay. And we can always go back and modify it. So, okay, we have the general form, and you're thinking, how do we recover this? It looks like garbage. Well, what we want to do is we kind of want to merge these together. So it's not just spheres sitting on spheres. That's what's going to make it look realistic, right? We want to somehow merge these together. Here's how you do that. First of all, take the geometry of the instances, realize it, just so it's real geometry. But to merge these, what I'm going to do is we have our points that we instanced, right, the sphere copies, and we have our original sphere all joined together. To merge these, what's the point? To merge these, what we're going to do is we're going to do a volume back and forth conversion. The same way that sometimes we go mesh to curve, curve to mesh, there's reasons to do that. Same with volume. So I'm going to go points to volume. So it's going to take each one of our points. This might lag a bit. And, I did realize these instances. Whatever, we'll go back to that. Either way, what this is going to do is it's going to take each one of our points that compose the mesh, each vertex, and it's going to generate a bit of a volume that we want to make way tinier. Something like that. I think the issue is we've joined this, even though we shouldn't. There we go. So it's going to take each one of the points, so the sphere, the squished one, and the spheres on top of the spheres. It's going to make a volume. And from this, we want to go back to a mesh. Volume to mesh. And you can see it doesn't look good, but it's kind of metaballed everything together because the volume kind of turns it into this just density cloud. So it's no longer separate objects, just a density cloud, and then we bring it back to a single mesh. So it's kind of like a fancy remeshing. So it kind of, I mean, it does not look bad, it just looks horrible. This is like a swipe left for sure. How do we make it look better? Well, first of all, it's basically just playing around with these remesh settings. We want to bring down the radius, but not too much, or that happens. The issue is if you bring down the radius too much, it almost looks like separate objects again. So we're just going to play with this. We're going to bring up the voxels, which is going to increase our resolution, but it's also going to make it look more kind of blocky too. So I'm just going to increase this, and then the key here is once you have like a shape that you like, take the density, bring it down. This is kind of the smoothness parameter. But I don't like the settings we picked, so I'm going to do that, and then bring that density down. Oh yeah, that looks pretty okay, actually. So this is kind of the approach we use to merge these together. So now the question is, can we make this look good? And I think so. So now we just got to play around with numbers until it looks okay. So you want to increase the radius until it kind of looks more connected, and play with the voxels and the density. I don't know. This is kind of like to your taste kind of thing, pun intended. But I like the look of that. And again, remember, all of this is dependent on the original spheres. So if we kind of randomize the scale more, we get a different kind of look. So I'm going to randomize the scale more and increase the amount of spheres we generate. This will make it look more layered, I believe. And we can also decrease the height that it shows up in. There we go. That looks pretty okay in my opinion. So again, the key to this is maybe just finding a seed that you like. That one actually looks pretty good. Okay, I'm happy with that. Oh, and also for smoothness, so we have the density trick. Don't forget, easiest trick in the book, set shade smooth. Now it looks more connected, okay? Because we've smoothed along the normals. So we've created a custom ice cream generator. You can play with the seed, the distribution, whatever, but also just the original shape, so you could rotate it. Do remember that the instancing kind of depends on it, and it's always going to be on the bottom. So don't do it too much, otherwise it will look like an egg, which is whatever. But play around with that. play around with the scale, whatever. So I'm pretty happy with this. Of course, you can always do a final transformation. Yeah, I guess before the set shade smooth, it doesn't really matter. And you could just move this thing up and down now that it's a single blob and you know what it looks like. And scale it. But okay, we have the ice cream. Let's say we're happy with it. I'm not, but it looks like 95% of the way there. The rest of it is just picking numbers that look better. The last piece of this, so I guess let's take all of this. So this is our ice cream group, which I did promise you that this would be a lot conceptually simpler, and in terms of the number of nodes simpler, it seems to be. So I'm going to take all this. We're going to frame it. So this is now our ice cream. So we have cone, ice cream. Now the final thing is let's make sprinkles, which is the easiest thing since we've instanced particles all fucking day, okay? So let's make sprinkles. I'm just going to go for basic kind of capsule cylinder-y looking sprinkles. But we want to do it smart anyways. So we want to make sprinkles. We're not going to distribute it everywhere. We only want to distribute it on the ice cream, not the cone. So just like last time, distribute points on faces. Sorry, I keep doing this. My ear is itchy. My hair is getting longer. I shower, but my hair is getting longer and it's dry, you know. Whatever. I guess, it doesn't really matter if we do the set shade smooth or not. Either way, we're going to take the ice cream group. We're going to distribute points on surface, so let's visualize this. Increase the points. Each one of these gets a sprinkle. And, of course, we're going to make this make more sense. Just like the sphere thing, we said only distribute it in certain selections. We'll do that. But for now, let's just put a sprinkle on each of these. So I'm going to instance on points. What are we going to instance? A sprinkle. And we'll make a good-looking one in a second. But for now, a cylinder. But not one that is that big. A tiny cylinder. And we want to join this with everything from before. So let's see it all together. Okay, so there are our sprinkles. They look horrible. Let's fix it. First thing, the cylinder's too thick. And there's a lot of things that are wrong with this, but it's actually not too many. Cylinder's too thick. Bring down the radius. So we're changing the original cylinder that gets instanced everywhere. So it's going to fix all these. Okay? Already looking better. Next thing is they're all pointing upwards, like the sprinkles are sentient and they're there to fucking rip up your tongue. We don't want that. We want them to look natural. So for each of these, we want them to be aligned to the normal. You might think, oh, use this normal. Don't. Just take rotation, connect it to rotation. So now they're all going to be pointing outwards, even more menacing. But you can see there's a bit of order now. It's relative to the normal. Basically, this rotation's the Euler version of this normal. Don't worry about it. We're going to take this. We're going to add a vector. Just rotate it by 90 degrees, which is pi over 2 radians. And now you can see these sprinkles are all flush with the surface. Beautiful. Final thing. Not really. One of the final things is now that they're all flush with the surface, they all still kind of look very like ant-like, and like you wouldn't want to eat this. It's a bit creepy. They're all pointing towards the top where their leader lives. We want to randomize this a bit more in terms of orientation, so I'm just going to rotate instances. You could do it here, but order of operations might be an issue. So we want to randomize the rotation. Let's use a random value. Let's use a vector. Connect this to the rotation, 0, 0, 0. Now, normally it'd be the z-axis you want to reorient, but because we did a thing here, I think it's going to end up being the y-axis. There we go. Just pick a high number. Basically, we're generating a random rotation vector for each of these that, gets rotated. So already this is looking a bit better. But the sprinkles aren't very sprinkle shaped, so now let's fix that. I said I would. So for the cylinder, to make it a capsule, just subdivision surface, in other words, smooth it out 2 times. And to make it not look broken, just add some side segments. It doesn't look beautiful, but if you zoom out, shouldn't be too bad. And let's also do a set shade smooth. Looks okay. Once you zoom out, you can't even tell. Okay, so we have sprinkles. I'm thinking we should make it so that no 2 sprinkles can be on top of each other. That's not happening currently, but we bring up the density. And you're going to start noticing these 2 are kind of touching. I'm trying to find a better example. Maybe. There we go. Sprinkles can be, by chance, distributed on each other. This kind of looks like the Mason's sign or something. To fix that, go to Poisson disk. This is going to be the same thing as before, right? We're scattering them, but this time we also have this little slider that says, here's the threshold. You can spawn points, but make sure none of them are within this distance of each other. Okay? Bit more randomization. Let's actually divide this by 2 so we could have more. Bit more randomization. Let's also randomize the scale because we can. So another random value, set it to float. We know the drill here. Going to speed through this part. So I'm going to randomize the point scale. So this is going to make them way bigger because on average they should have been 0.01. And our random value goes from 0 to 1, so they're going to be huge. The maximum should be 0.01. And the minimum, maybe not 0, but 0.01 divided by 2. There you go. So some sprinkles are big, some are small. Beautiful. Okay, finally, this is the last thing for this tutorial. As we have sprinkles distributed everywhere on this ice cream, which looks okay, but if you think about it, you have this cone, somebody scoops ice cream, it gets this globular shape, and then they pour sprinkles on top. That means there's no way that sprinkles should be down here unless they melted and traveled. So just like before, we somehow want to generate a selection of the faces that sprinkles would actually land on. And a good way to describe what I was just talking about is it'd be any part of this mesh that's pointing upwards. This part of the mesh that's pointing downwards, no sprinkles would be there. So how do we extract which parts are pointing upwards? Good question. And once we do, again, we're going to do a selection kind of thing. Well, this is exactly what normal coordinates are useful for because they show us the direction perpendicular to the surface. In other words, which way is it pointing? We want to say which normals kind of fit our criteria. What are our criteria? They're facing upwards. Mathematically, we describe it like this. Take the normal. We're going to take the dot product. If you've never seen this before, keep it that way. But if you've never seen it before, a dot product just takes 2 vectors. So in this case, the normal, and I've set 0, 0, 1, the z up vector. It takes both of these and outputs a number between 0 and 1. What that number represents is the angle between both of these. In other words, when this output is close to 1, it means they're facing the same way. In other words, the normal's pointing up in this case. When it's close to 0, or negative numbers even, maybe, it's not. So if I take this dot product, connect it to the selection, you can see it kind of already did it. Let's see. So we have nothing on the underside and only on the ones kind of facing upwards. If you want a bit of control, just set this to like a greater than, so we have a threshold. So you can see if I set this to a very high number, like 0.9, only the top 10% live. It's going to be only the ones on the very, very top because those are the ones perfectly upwards. But we kind of lax the rules. Skateboarders are allowed, on weekends. We lax the rules. I don't think you even need this greater than. And it's only the ones that are roughly pointing upwards. Because again, this outputs a negative 1-to-1 gradient, I believe. So final thing, let's just do some aesthetic stuff. I want more sprinkles, bump up the density, and they could be a tiny bit closer. There we go. So what do we have? We have a waffle cone that can be fully controlled from the resolution to the shape. And by the way, in my original, I added a noise function. It's too much already. I don't know how long we've been going for, but I can tell you guys are getting tired, even though I can't hear you. But if you look at the viewer retention, it drops off over time, so whatever. We can control the shape of this cone, including the opening size. Let's not do it like that. Let's do it like that. The opening size. We can control the shape of the ice cream, including this globular thing using the seed, which will also change the sprinkles that have their own distribution. So there you go. I feel like this looks pretty similar to my original. Let's open up the original. I called it Cream Demo. You could see, roughly same. You could see mine has a bit more like noise and stuff, but it's the same thing. So I think I'm happy with this. And again, this is part 1 of a 2-part series, and you can see why I divided it into 2 parts. I would have had a heart attack if I wasn't recording there. Okay. So there you go. There's part 1, a 40-minute monstrosity of a tutorial. Hopefully you enjoyed, and this is the part of the tutorial where I start talking about Patreon, but don't leave. There's purpose to it. So as I mentioned, you can get this blend file as it currently stands, and I'm also going to add the materials on Patreon. But what you are seeing right now is a list of 740. It always increases after I say it because it's just that good. People that are active patrons. What do you get in return for clicking that link in the description other than funding this tutorial channel and CG Matter? Well, you get three things mainly. The first thing is you get early access to tutorials. You can watch tutorials before everybody else, usually a day early, sometimes a week early. Watch it before everybody else. That's the lowest tier. Super easy stuff. You get a bunch of stuff before anybody else does. Fine. Second thing, this is the most valuable one in my eyes, the blend files you can get access to. This one, the previous tutorial, any project I've worked on in the last 3 years, pretty much I've uploaded on Patreon. So there are hundreds of blend files for you to download there, spanning back a while, back when 2.8 came out. So get a bunch of assets, like a stupid amount for very cheap. And third, and this is the highest tier, but it's also kind of the most exclusive, is you also get exclusive tutorials that are not available for free on YouTube, that go more in depth. This is a good example of one where it's like a 40-minute geometry nodes tutorial. That is the kind of stuff that's posted on there. So this month, I believe I did a bagel that inverts. I showed a clip of that on the CG Matter. It's very technically hard to explain, and it's even harder to make because a bagel is not that hard to make with geometry nodes, but to set it up in a way where it can be inverted, you have to do some weird stuff. So all of that available on Patreon. Thank you to all the active patrons, and thank you, regardless of whether or not you are one, for watching a 40-something minute video. Not many people have that attention span. Hopefully you either learned something, you learned something, that followed along, whatever. So I hope you enjoyed. I hope you learned something, and I'll see you on part 2. I don't know if I'm going to record it today, but see ya.